Welcome to Thuma Mina Teaching. You are tuned into grade 9 mathematics, and today we will be looking at the surface area of an object. We will specifically be doing the surface area of a cube, a rectangular prism, a triangular prism, as well as a cylinder. So let's have a look where we're at. Now let's first look at the difference between area and surface area. When we calculate the area of a two-dimensional object, we simply call it area. When we calculate the area of a three-dimensional object, we call it surface area. Now, let's for instance say we would like to paint this box. Therefore, we need to calculate the surface area of this box to know the entire area that we need to paint. When we have a 3D object, we can lay this object down in the form of a net so that we can calculate how many squares added together will give us the total surface area of this box. The units of surface area is millimeters squared, centimeters squared, meters squared, and kilometers squared. Let's have a look at the surface area of a cube. When we look at this cube, I can see 6 squares, and I already know how to calculate the area of 1 square. Therefore, if I draw this cube's net, it looks like this, and now I can clearly see the 6 squares. Since I know the area of 1 square is side times side, I know I have to say side times side 6 times. Therefore, my formula for the surface area of a cube is equal to 6 times side squared. Now let's take a look at our first example. Let us calculate the surface area of this cube. I only have the length of one side, but since I know that for a cube I have a lot of squares, I know that all of the sides are equal. Therefore, every single side would be 5 centimeters. Now, to calculate the surface area, I can write SA for surface area is equal to 6 times side squared. Therefore, I can write 6 times my side, which is 5 squared, is equal to 150 centimeters squared. Always remember your units are squared for surface area. Let's have a look at the surface area of a rectangular prism, also known as a cuboid. When I look at this rectangular prism, it is clear to me that the top rectangle is exactly the same size as the bottom rectangle. It is also clear to me that the one rectangle on the side is exactly the same size as the rectangle on the other side. And the rectangle in front is exactly the same size as the rectangle at the back. Therefore, when I draw the net, it is clear to me that this rectangle is the same size as this rectangle. This rectangle is the same size as this rectangle, and the rectangle in front and the back would be the same. And therefore, I can write my formula for surface area 2 times length times height. Why do I say length times height? The surface area of one rectangle is length times breadth. But since this is a three-dimensional object, I look at the rectangle on the side, and this would be my length and this would be my height. Therefore, to calculate the area of one of these rectangles, I need to say length times height, but there are 2 of them. Therefore, I multiply it with 2. Plus 2 times breadth times height. This is my breadth. And if I want to calculate the front rectangle, I need to say breadth times height. And when I calculate the rectangle at the top and the bottom, I have my length times my breadth. Let's have a look at an example of a rectangular prism. Over here, I have my height, I have my length, and that is my breadth. Now, to calculate the surface area, we've already learned the formula. Surface area is equal to 2 times length times height, which is 2 times 10 times 4, plus 2 times my breadth times my height, which is 2 times 3 times 4, plus 2 times my length times my breadth, which is 2 times 10 times 3, which is equal to 2 times 40, which is 80, plus 2 times 12, which is 24, plus 2 times 30, which is 60. And therefore, I calculate my final answer as 164 centimeters squared. Now let's have a look at the triangular prism. Over here, I can see that I have two heights. One is a small letter height and the other one is a capital letter. Now, remember that for the triangular prism, the triangle is the base. And if you turn this object on its base, it will be clear to you why this is called your height. Now the small letter h is the perpendicular height of the triangle. The capital letter H is the height of your entire object when it is standing on its triangular base. Now, the triangular prism has a net that looks as follows. 3 rectangles that are not necessarily the same size, as well as 2 triangles who are definitely always the same size. Now, in your textbook, you will see that there is a formula to calculate the triangular prism surface area. But there's another easier method and I will show it to you now. You simply calculate the area of these 2 triangles and then you add the area of the 3 rectangles. Let's look at an example. I can clearly see the front triangle. I also see the back triangle. Then I see the rectangle on the right hand side. Then I see the rectangle on the left hand side. And then I see the bottom rectangle. Therefore, I see 3 rectangles as well as 2 triangles. My 2 triangles will always be identical. Now, to calculate the surface area, I know I have 2 triangles and then I have 3 different rectangles. They are not necessarily always the same size. Therefore, I say rectangle 1 plus rectangle 2 plus rectangle 3. Now, to calculate the area of a triangle, I need to say a half times base times height. And since I have 2 triangles, I need to multiply them by 2. That means I have 2 times a half times base times height. Plus, now I will work with the rectangle on the right hand side. I've colored it in blue. I clearly see that I have this length of the rectangle, but I still need this length. I have no idea what it is. Therefore, I first need to calculate it using Pythagoras. I have that these 2 will be exactly the same length, which would make them 4 and 4. And I know that my perpendicular height is 3, so I can calculate the hypotenuse. I can say x squared is equal to 4 squared plus 3 squared using Pythagoras. Therefore, x squared is equal to 16 plus 9, which is 25, and I can calculate x as 5 centimeters. Now, I know that this is 5 centimeters. Therefore, I can calculate the area of the blue rectangle. Since this length is 5, this length will also be 5, and I can say 12 times 5 plus the green rectangle, which I also know is 5 by 12, so plus 5 by 12 plus the red rectangle, that is the bottom rectangle, which is 8 times 12. Now when I calculate 2 times a half, it will give me 1. Therefore, I'm only left with base times height. Base times height plus 12 times 5 is 60, plus 5 times 12 is another 60, plus 8 times 12 is 96. Now I have to insert my base and the height of my triangle. The base of my triangle is 8 centimeters and the height of my triangle is 3. plus 60 plus 60 plus 96. And if I insert on my calculator 8 times 3, which is 24, plus 60 plus 60 plus 96, I can find my total surface area for my triangular prism as 240 centimeters squared. Lastly, let's have a look at a cylinder. When I draw the net of a cylinder, it looks like this. I have a rectangle with two circles. Therefore, I need to calculate the area of both circles, and I know one circle has the area of pi r squared. And then also I need to calculate the area of a rectangle, which I know is length times breadth. So I know that pi r squared plus another pi r squared plus length times breadth. Now, since the length of this rectangle is actually the perimeter of a circle, I know that the length will be equal to 2 pi r, which is the perimeter of the circle, which would be the length of this rectangle, times the height, which would be the breadth. So times height. Now, if we have to write that in a formula, I find that the surface area is 2 pi r squared, since it's pi r squared of the one circle plus pi r squared of the other circle. And then I add the area of my rectangle, which is 2 pi r times height. Let's have a look at this example. Over here I have a cylinder. The diameter of the cylinder is 14 centimeters, and I know that with the formula of a cylinder, I need the radius. Therefore, I need to divide my diameter in 2, which would give me a radius of 7. Now, the surface area of a cylinder is 2 pi r squared plus 2 pi r times height. Now I can simply insert the height and the radius. The radius I've calculated as 7, and I insert radius again, and now I simply insert the height, which is 10. If I calculate this on my calculator, I find that it's 238 pi. And if they ask for 2 decimal places, I simply press SG on my calculator and I find the answer of 747.70, neatly rounded off to 2 decimal places. And always remember your units, centimeters squared.
Finish strong and do the following questions by yourself. Remember, the answers follow.
We hope you benefited from this video lesson. Our vision at Thuma Mina Teaching is to accelerate access to quality education. And our dream is to see learners across South Africa flourishing academically. We are a non-profit company and we are entirely dependent on public support. We produce lessons at the rate at which they are funded. As soon as a lesson is funded, it is published to the entire growing audience of Thuma Mina Teaching. Please consider taking hands with us in one of the following ways. Share our content with others that can benefit from it. A great way to support us is to find us on My School and to add us as your beneficiary. And consider donating towards a lesson or ask your company's CSI department to partner with us. We are a PBO, so your donation is tax deductible. Our contact details you'll find on our website www.tmteaching.co.za. If you want to reach out to us, please email us on admin@tmteaching.co.za.